So 5 on the front, correct? Yep. All right, so we're going to just go over 1 or 2 problems from the summer review worksheet, and then I'll come around and check your homework, and then we'll kind of get into the notes. Number 5, this one, oh, this is probably a mistake. It says 6x plus 56 equals 2x. There is no factoring that you really have to do for that one, Virginia. So what would you do to solve for x?
2x reverse of 4x with 56 equals 0.
And then how do you get x by itself?
You factor out 4.
You could factor out a 4, and when you factor out a 4, you would be left with,
X plus 4x plus 14 equals 0.
and then the zero product property says once it's in factored form, you take whatever's factored and set it equal to 0 if it contains a variable. Well, x plus 14 is the variable, so x would be negative 14. The 4 doesn't have a variable, it just kind of stays out there. You could divide by it to get rid of it if you wanted to, but x would just be negative 14. That's sloppy. Is there another question from the packet that you wanted to go over? So if you have this and you have it done, I'll take it. It's not due till Friday. But if you wanted to turn it in to get it out of your hands, if you don't want to lose it, fine, I'll take it from you. Nobody has any other questions you want to talk about today? I'm not going to grade it for complete accuracy. Any other questions? Okay, so I'll be around to check that. What I would like you to do while I look at your homework and possibly collect this, in the notes packet form, and I know I'm asking to have like 3 things on your desk, but in the notes packet, there is a warm-up at the top talking about transforming points. And I would like you to see if you work with somebody next to you, but see if you can kind of decide what happens to the original point, what kind of transformation takes place. Sounds a little bit like geometry. But please, check with the people around you. There's just 3 of them. Okay. All right, so let's look at the warm-up here. So if the original point is xy, that means it's going to be somewhere in this first quadrant. We'll just say it's at 3, 2. What happens when you make the x negative, Brandon?
It flips over the y-axis.
Yeah, so it goes over the y-axis. X is negative, but the y value is the same exact height. Instead of saying flip, what would be a better math term? Beginning with an R.
Rotate? No, I forget. Reflect.
There you go. So we'll say it reflects over the y-axis. Brandon, you're not wrong. Just reflect sounds a little more mathematical. So then the second one, we have x negative y. So that means we're down here. X is the same, but y becomes negative. So Jenna, what happens with that one?
It reflects over the x-axis.
Yeah. And then the last one has a negative x and a negative y, so that's located over here. What's that called, Brandon?
Does it have, it has a specific name,
You could, there are two different ones that you probably could say.
I don't know the name, but I know it just flips over one and then the other.
So it flips over one and then the other. Can anybody interpret what it's saying? Or have another way of saying it? Virginia?
So it rotate 90 degrees around the origin.
So it does rotate. You could say it's a rotation, but not 90 degrees.
Oh, sorry.
180 degrees, yeah. So you could say that it rotates 180 degrees. What else could you say? You could call it a reflection over what?
The origin.
The origin, yeah. We will actually see things reflect over the origin. And that happens when x and y are both negative. So that exact point is just like flipping over the origin. And that origin is its reflection. Questions? Okay, just with the homework, couple of things before we get into these wonderful graphs that we're going to look at. The questions in 4, 5, 6, and 7, where it says determine the quadrant which x and y is located. So if x is greater than 0 and y is less than 0, like if you think about that, get a little picture in your head. What quadrant would x be positive but y be less than 0? Chelsea? Why the fourth quadrant?
Because the x is still positive while y is
Yeah, so here we have a positive x. Down here we have a negative x, negative y. So this side is all positive x, but the y is negative down here in the fourth quadrant. So the right side is all x being positive, but y also has to be negative. So it has to be down there in the fourth quadrant. Looking at number 7, this one says we want x times y to be bigger than 0. So thinking about like the ordered pairs and the 4 quadrants, why would x times y be bigger than 0? Like, what would happen even with numbers? If you're multiplying 2 numbers together, Michael, why would they be bigger than 0? They're both positive. So if they're both positive, Michael, that means what quadrant would it have to be in?
Quadrant
Yeah, so like if we had positive 2, positive 3, that would have to be quadrant 1. But what else could be possible if I'm multiplying 2 numbers together, okay?
1, 2 negatives.
Yeah, you could have 2 negatives. We could have negative 2 times negative 3. But when you multiply them together, that's still bigger than 0. So that would be quadrant 3. So there's actually 2 cases for number 4. And also, I'm sorry, number 7, not 4. Number 6, it says y is less than negative 5. Well, y is negative down in quadrants 3 and 4. So that also has 2 locations. But Number 7, I think, was the one that tripped up a lot of people getting that second option. So 2 positives remain positive, but multiplying 2 negatives still give us a positive value. Any other questions on the homework? Okay. So basic graphs, and I'm fairly certain that today does not end early. Let's hope. In your notes packet, just kind of looking underneath the warm-up, we're going to look at 6 graphs that we did last year throughout a couple of different chapters. The goal is with Chapter P for you to get a good foundation of review, which is really only 2 weeks, so it's a really quick review, for us to build on. But you need to have a strong basis so that you can quickly use those skills to start applying the pre-calculus skills. So we're going to review 6 graphs. These 6 graphs we'll also review again next chapter. That's how important, like remembering what a graph looks like. And really, it's just the shape. Can you see the equation and match it with a picture pretty quickly, or a picture that you have in your brain pretty quickly, instead of like trying to plug it in the calculator, getting the calculator to graph. I want you to be able to just kind of have things in your memory bank to be able to quickly recall. So the first graph that you would have talked about probably in pre-algebra would have been just the line. So an equation of a line. What is a line? I mean, I know it's a line, but what does it line, like the equation look like? Alex? Yeah, y equals mx plus b. And Alice, just a little reminder, m is the, so it's the coefficient, but what does that tell us about the graph?
The slope.
Yeah, there we go. So m is the slope, the b is, yeah, there you go, the y-intercept. So throughout all 6 of these problems, we're going to use the same 2 numbers. The goal is to show you how those same 2 numbers can be consistent, but how the graphs can change, except for this one. This is the only one that doesn't really kind of work with the values. So we're going to just use 3x plus 1. And I'm going to use that 3 and 1 in every single problem. So when you graph, where do you start? When you're graphing a line, you begin with what?
The y-intercept.
Yeah, the y-intercept. B is the y-intercept. Begin with B. So you start with B, you begin with B. The y-intercept is a positive 1. And then, Brandon, how do you move your line?
Up 3 and to the right.
Yeah, you move with the slope. That's how your line moves. In this case, it's moving up 3 and right 1. Or we could fall 3 and go backwards 1. And we have a line. So most basic graph, the first one you ever graphed was a line. The next 5, I'll show you how they are all related to each other, even though you might be changing the power, you might put a couple extra little symbols in it, but really each graph is related to the one before it. And then it starts with the parabola. This is chapter 4, nobody's favorite chapter, or everybody's favorite chapter, right? Everybody loved chapter 4. No. So thinking back to chapter 4 last year in the parabola, how about the shape? Let's just talk about the shape of the graph. Alice?
It's like a U sort of.
Yeah, there you go. Exactly. It's a U. How about the equation? What was special about the equation? What had to be in the equation to make a parabola? Brandon?
X squared.
X squared. So a parabola was always x squared. Alright, so there are 2 forms that we actually 3, but I'm going to kind of review 2 with you. The one form that we talked about was ax squared bx plus c. That's the form that we factored like crazy. So we did the factor by grouping, multiply the 2 numbers, break down the value to get it to factor. We're not going to use that to graph because we're doing basic graphs, and this actually takes a while because there's a couple things that you have to find in order to graph it when it's in this form. This is called standard form, although it's not quite standard. Standard usually means it should be basic easy, and this actually isn't the basic easy form. The other form that we used had an h and a k in it. And I don't think you guys like this form, but it actually is the easiest way to graph a parabola. Every other graph we also did last year also used H and K. That H and K told us an important part about the parabola. Does anybody remember what that important part was in the parabola?
Is the minimum or maximum?
It is the minimum or maximum. And that name begins with a V, Michael.
The vertex.
Awesome. That H and K in each graph is where we always will begin a graph. Now, it might not be the vertex in every graph, but it's an important piece of every graph. The one thing that you have to remember is that the H is opposite of what you see. And that's because when it's with X in the parentheses, it actually moves the opposite direction. So even though it says X minus, the graph is actually going the other way. So we're going to use, because it's basic, I'm going to eliminate the A. All the problems will not have an A in front. That A makes it wide, it makes it narrow, and therefore it's no longer basic. But we're going to use X minus 3. This time it's squared because it's a parabola, and then plus 1. Every single problem is going to look like this. X minus 3 plus 1, but the power is going to change. The notation will change. So, Chelsea, what's the vertex? 3, 1. So here's our vertex. We're going to start our graph at 3, 1. So over 3, up 1. We know it needs to be a U. Instead of making a T-chart, referring to your calculator, trying to use the equation, we're going to do a quick little mental graphing. So the only thing we're using from the equation is 3, 1. Now the rest of it is just a little bit of mental math. X is squared. That means whatever you do to the X, to get Y, you have to square it. I'm not worried about subtracting 3 and adding 1. So I'm going to go to this point that I already have up here and move to the right 1. That means I'm applying a positive X value. And it's just 1 because I'm moving a distance of 1. What happens when you square 1? You get 1. So that tells me I have to move up 1. Because right is X, up is Y. So Virginia, if I go right 2, 2 squared is 4. So that tells me I now need to move up 4. So however far you move right, if you square that number, that tells you how high you're supposed to count. Now, I know your graphs are really small, but just, I'll show you one more. If I move right 3, Virginia, how high would I go up? 9. It should be up there on my graph. You don't have a graph size. So then if you apply that to the other direction, if I move left 1, that means X would be negative 1. Negative 1 squared is 1. If we move left 2, negative 2 squared is? Yeah, that's right. It's 4, and then I could go left 3 and get 9. So instead of making a T-chart, trying to use the equation, plug it in, trying to get the calculator to graph, you can just do a little bit of mental math that you're just squaring an X, which is pretty easy. Square 1, square 2, square 3. And then you have your parabola graph without doing all of the stuff that we did last year, which is pretty basic. Questions? So if you didn't get it the first time, there are 4 more graphs that we're going to do exactly the same way. The only difference is that this power is going to change. But I'm still going to say if you move right 1, 1 squared is whatever, 1 cubed is whatever. So we're going to use that same concept. So if you look underneath, I think this is the cubic graph. So if we have a cubic graph, we'll talk about the equation and then see if we can get a picture. Libby, what would change with a cubic equation? What's going to be in it?
The square would be a cube.
Yeah, the square would be a cubed. So x minus h is now cubed and then plus k. Notice the form didn't change. Just the power is now a cubed. Anybody remember what this looks like? Brandon, you think you remember?
The soap formula?
Oh, we would have to use soap to factor it, yeah. Libby?
But it's like 2, like, I don't even know. Like, it has like 2, like, hill things.
You're right. If
Yeah.
it was a more interesting one, it would have 2 hill things. If I didn't have those 2 hill things, it would look something like this. Yeah. So because it's basic, it's just going to kind of start at the bottom and work its way to the top. It's like a swooping curve. This swoops upward. The h and the k are still part of the graph, but it's called a critical point because there's not a vertex. Critical point is just that important piece that you're pulling from the equation. So exact same equation. I want you to use the same numbers so that you can see how one little power changes the shape of the graph. So x minus 3 cubed and then plus 1. So that 3, 1 is no longer a vertex, but it's still a point we're going to focus on in the graph. So we're going to go over 3 and up 1. So the number in the equation is always the point that you begin your graph. And then ask yourself the same question. So not using the equation, I'm only using the cubed. Chelsea, if we move over 1, 1 cubed is now 1. But if we go over 2, 2 cubed is 8. So now we have to move up 8. Which probably is off your graph. Just draw it up high. But we know to go up 8 because we're moving x is 2, cubed to get y, so 2 cubed is 8. Now if we take it in the other direction, Asia, what is negative 1 cubed?
Negative 1.
Yeah, what's negative 2 cubed?
Negative 2. Oh, wait.
So negative 2 times negative 2 times
Oh.
negative 2.
Negative 8.
Negative 8. So go left 2, but down 8. And that's how you get your graph to kind of curve in both directions. So instead of it going both of them up, the one side goes down, the other side goes up. Questions? So that was chapter 5. The parabola was chapter 4. On the other side is an absolute value, which was chapter 1. What makes an equation the absolute value in a symbol? Shannon, do you remember? Anything? Did they almost fall over?
The 2 lines on both sides.
Yeah, the 2 lines on both sides around the x. So instead of having like parentheses and it being cubed, it just has those 2 absolute value bars. How about the shape? A V. Yeah, nice job, Brendan. Brendan, did you just study math all summer? No? Okay. I didn't either. I let my brain break.
I just don't remember this.
Oh, good. Well, thanks.
That means you're a good teacher.
Well, thanks, Brandon. Full of compliments today. Nice. I like it. I think we did absolute value in chapter 1. We may come back to it after a while. Pull it back in for graphing something. So this has a vertex of h and k. Same equation. So absolute value, x minus 3, and then plus 1. So that 3, 1 is now the vertex because it's a v. So the absolute value has a vertex, the parabola has a vertex. And then go through this graphing the same exact way. So if you move right 1, what does the absolute value do to 1? So Libby, what is the absolute value of 1? 1. What is the absolute value of 2, Libby?
2.
What is the absolute value of 3?
3.
Yeah. Okay, I'm going to trick you. What happens if you go negative 1, Libby?
1.
Oh, you weren't tricked. Negative 2 would be?
2.
And the absolute value of negative 3 is? 3. That's how you get that V formation. Absolute value is taking your number and making it positive. So that creates the V. So whatever you do with X, apply the symbol. And that's how high you go for Y. Any questions on those 4? The last 2 would be the square root and the cube root, which we did in chapter 6. I think that was the radical chapter. So a square root symbol, that's the little check mark. Our radical. When you have square roots? What limitations do you have on square roots? It can't be negative numbers. So that means when you graph it, you're only going to have the positive side of the graph. You're not going to have both sides. So in a parabola, I'm able to have a positive and negative side. In the absolute value, we're able to have a positive and negative side. In the x cubed, we're allowed to have positive and negative. But now because of a square root, you only have half of it. So if we only have half, we just have like a hook that's hooking to the right. So square root x minus 3 plus 1. This again is called a critical point, not a vertex because it isn't a vertex. Just the starting point of the graph. It's still at 3, 1. So Eris, what's the square root of 1? So if I move right 1, the square root of 1 is 1. What's the next x value you think we should use? Why 4? Yeah, it's a perfect square, which is 2. So instead of moving right 2 and taking the square root of 2, which is 1.41, but if you don't have it memorized, why use it? Go 4 to the right. 1, 2, 3, 4. The square root of 4 is 2. Eris, can you move left and take the square root of negative 1? No. So this is it. It stops here. There's nothing to the left because you can't take the square root of negative 1. It doesn't exist. That's why that graph is just opposite. Homework is just the next page of that. Okay, so I'd like you to see if you can try the cube root graph. Try and apply the same exact steps that we've just done. Use the same exact numbers. See if you can kind of get a sketch as to what this is going to look like. So Michael, if you take the cube root of 1, you get 1. What's the next number you can take the cube root of? 8. So x is 8. You're taking the cube root of 8. Remember, you're not cubing it, you're cube rooting it. So the cube root of 8 is 2. 1, 2, 3, 7, 8, and it's 1 off. So here is the graph. Can you take the cube root of negative numbers, Michael?
Yeah.
Yeah, what's the cube root of negative 1?
Negative 1.
Negative 1. And then the cube root of negative 8 is?
Negative 2.
You're not allowed to take the square root of negative numbers, but you are allowed to take the cube root of negative numbers. Because it's a cube. Any odd power, you're allowed to have a root of. So that one does have a negative side. So again, we did the cube root of negative 1, which is 1. And then the next perfect cube is 8. Since we're on the negative side, it would be a negative 8. Any questions with graphing those? So each one we did exactly the same way. We used the same process. Focused on the number and then like the power or the radical that was in the problem. There's one other thing that's left here and what happens if you use your calculator. How can you use the calculator to help you graph some of these? And some of them, because the numbers are so big, you will have to use a calculator for. So the first thing, make sure that it's in y=4 form. If it isn't, you need to solve it to get it to be y=. That's the only way the calculator accepts equations. Must be y=, whatever the y has to equal. The second step would be to enter it actually in your calculator. And that goes in the y= button, which is why it's y=4 form. And then of course you press graph. And then the last part deals with what we call a viewing window, a viewing rectangle. This looks like a sad rectangle. So if this was what I saw in my calculator, you don't have to draw this, this is just a visual here. Sometimes when you graph, you only see part of the graph. And maybe it's supposed to be a parabola, but you only see this. You're like, okay, well it was supposed to be a parabola, but I got 2 buttons. That's because the vertex is way down here and it's not in your calculator screen, it's too low. So you need to change the window. And there is a button on your calculator that says window. There is an X-min and an X-max. There is a Y-min and a Y-max. Those are numbers that you are going to have to change. We'll work on that throughout the entire year. But using your equation and the numbers that are in the equation, if it deals with y, like I can't see the bottom part of my screen. That's the y, because y goes low and y goes high. So I need to change the y-min if I can't see the bottom. Or maybe you can't see the top, so then you need to change the y-max so that you can see the top. Questions? So your homework, it's called Basic Graphs Worksheet. It's just the next in the packet. I'm just going to take a peek at that. So there are 9 graphs that you'll do without a calculator. It says you must be able to recognize the shape of these graphs based off of the equation. If you look at a question like number 4, and if you don't have it out, number 4 looks like y equals the square root of x minus 3. What happens if there's not a number out there? It's just 0. So here's my h, but k is missing, so this would just start at 3, 0 instead of starting at 3, 1. There is a word problem on the back that you're going to have to change the window for. And you might have to make it really big because the numbers in the problem are really big. So when you look at your equation, if it has huge numbers, your calculator has to have huge numbers in it as well. So that is one that, like, trial and error. Put some numbers in, hit the graph, see if it changes the screen. If it doesn't, go back to window, put a couple other numbers in. Anyone have questions? So factoring tomorrow. So prepared letter, if you didn't turn that in today. How about Google Classroom? Anybody have problems with getting on? I knew initially I didn't have the form uploaded. It's up there now. So I did it for one class, but not for 4 other classes. Nick, you glad you don't have your Spanish? Yeah. I'm done with it. Thank goodness. Evil guy that he is. Did he pick on you a lot?
Not really.
No? Well, see, that's good then. I'm going to tell him to pick on Kate.
Mary puts on Ben Swayze and Sam County.
Oh, they're all you. Is that you? That first period. That's probably going to be a lively class, especially first period. Usually first period, like my first period so far is comatose, but they're all ninth graders. Which I guess last year's ninth graders, you were so scared of me. I don't know. Was I scary?
No.
Maybe it's because it's only the second day. We'll see how it
I
is at the
think
end of
I
next
was
week.
more scared of like the older people.
In the class? Yeah, that's true too.
It's also hard to actively think with quiet when you have people like Gray in your class.
I know. Well, and like that, you had 30 in your class.
I miss Ethan.
Where did he move to?
Ohio.
Ohio.
Yeah.
That's the sacred seat.
What part of Ohio? You don't know.
Cleveland.
Cleveland? Cleveland? I'm going to Columbus in 2 weeks. I thought maybe if it was Columbus, I could visit him, but
No.
no.
Maybe the reason they're so quiet is because they're not afraid of you now, but they're worried if they do something wrong. Because I mean, my chemistry class was like silent this past 2 days. Like,
Yeah.
yeah,
Yeah.
she's like, you know, you guys can talk.
Do you miss high school?
Yeah.
Oh, I love that woman.
Yeah. Love that.
And it helps that I know all of you. I don't know any of them. They don't know their names, who they are. It'll get better. Have a great day.